So let us now try writing a piece of code which will check if a given element k is present in a list L or not. Going to be pretty straightforward code. Let's call it the obvious search. In fact, we have done this already, so I'll be a little fast here. Alright, so what do we do? For x in L, you go through all the elements of L, and if in case x is equal to k, then you return true. Okay, and then return 0 here. Right, as you can see, the return 1 here returns true only when you encounter x equals k. Okay, when you see some element of L, I mean if k is encountered in L, it returns 1. If not, it returns 0. So point to note here is that the moment it returns 1, keep it in your mind that it stops. It stops. The moment this happens, it stops. It never comes down to the next one. Alright, it just stops there. Correct? Okay. So I hope this works well. Let us try seeing this with the execution of the code. Right? So what do? I say L equals list of range of some 100. Okay, let me print L just so that you see that you have created the list. And what I do is I will also print obvious search L. Let me see the element 2, which obviously belongs to L. Let's see, let me run this search.py. That's the file name. This is how you run on a command prompt. As I said, this is not Spider. This is a straightforward interactive Python, IPython. So you see, run search.py, it displays your the list. As this reads list range of 100, it displays it prints L rather, I'm sorry, this prints L and then prints obvious search L comma 2. 2 is present, so it returns 1. Correct? So what we'll now do is maybe remove this, comment this, and then try to see if it says 0 for this. 200 is not present here, right? Let me clear the screen and then try to execute the code and see, yes, it is saying 0. Okay, very good. So I'll come here, code verified, working fine on the examples given. Right? So I will now teach you people a couple of things before going ahead. All right, just concentrate. Let me just zoom this just so that you are able to see the entire screen. Now you see, I'm going to use a couple of ideas. I'm just training your mind before I use it. I want to see how long something takes. Right? For instance, when I say for I in I'll say let's say s equals 0 for I in range 100, s equals s plus I. Alright, and then I'll print s. Within parenthesis, print s. Alright, it prints 4950. Correct? Okay, so which is the sum of the first 100 numbers. Alright, so but then I would like to see how much time this takes. Alright, this particular thing. So what I'll do is I'll define a function. Sum of first 10 numbers, let's say. So answer equals 0, very similar, very same thing. I'm trying to write a function for it. You can write it on the interactive Python shell too. You need not necessarily write it in a file and then execute it. Answer equals 0 for I in range n. Okay, answer equals answer plus I. Okay, and then I'll say return answer. Boom. So when I say print sum of 10, it will compute the sum of 10 numbers 0, 1, 2, 3 up to 9. Correct? And when I say 100, it will compute so much. Alright, please note in interactive Python here I can always say print hello world, okay, and then put a semicolon here and then say print hi. This is the second command, and put another semicolon and then execute a third command, right? So look at this first command, and then I'll print sum of 10, okay, and then I'll print last one. All these three things get executed here. Alright, this is how your IPython works. Even in Spider this is true, you can just check that. Right? So what I'm now going to do is, let me clear the screen. I had defined this sum, right? So what I'll do is I'll say import time. You'll see in a second what I'm trying to do. Whenever you say time, it will tell you the time from the past several years, right? It actually starts from some date, right? And then you see it is now a few seconds post that, right? So on and so forth. So if you want to know more about it, you can always say returns the current time in seconds since epoch. Epoch, I think, is the time starting from some particular point. Alright, you can just Google for it. I don't want to get into the details. It's all there. The idea is that this is some time that will be displayed whenever you say time. Alright, see now it's 30 seconds past that. Alright, now the point is whenever you say a equals time and give it some time and then say b equals time, now b minus a will actually be the difference in the execution of this sentence. I hope this is clear. This is pretty straightforward. Maybe you should do the coding with me just so that you understand it. Let me clear the screen and then now say a equals time and then put a semicolon, not execute it, okay, and then say print sum of 100, okay, and then say b equals time, okay. Now answer is given here, but a is the time that is recorded before the print statement. B is the time that is recorded after the print statement. So essentially b minus a should tell me the time it has taken to execute this. It is 6 into 10 to the power of minus 5 seconds. Okay, it's 0.00006 seconds. Alright, roughly close to nothing. So but what will happen if let's say let me also print b minus a here just so that it prints right there itself. This is the answer and this is the time that it has taken. Okay, it is roughly the same time no matter how many times you execute. You see, I mean, some minute difference is always there, but it is always in the order of this 0.000 and then something, 0.000 and then something. That's what is happening here also. 10 to the power of minus 0.5. It is in a different format. That's all. So now, will it be same if I find the sum of let me clear the screen. Sum of 100 numbers was so much. Sum of 1000 numbers obviously should take more time. Right? Surprisingly, probably there's a very small difference, because for a computer finding the sum of 100 numbers and 1000 numbers is not so significantly different. So let me find the sum of 1 million numbers. Now let me see if it still takes something like this. Okay, so you see this is slightly higher. Finding the sum of 1 million numbers takes close to 0.04 seconds. Okay, so let me increase the complexity. Here again I'll come here and then make this some 10 million, 100 million, maybe this is 100 million, as you can see. Okay, and then execute this. You see it's taking a long time. Probably that was too much. It has taken flat 4.36 seconds. Let me execute once again. It should take around that. Okay, sometimes it is more, sometimes it is less. So it's exactly the same, very close to the previous one. Again execute it. Okay, if you have a lot of time, maybe you can change this to a billion. To put one more zero, it becomes a billion. So I don't have a lot of time, so I'll reduce 1 0 and make this 10 million and then execute it. This is much better than this, roughly 10 times less, you see. Okay, so you now understand how to use the time function. In fact, there are many other functions in time. You see, I mean, you can always take a look at it. And this is the time function that I have used here is the simplest of all functions according to me. There are even complicated ways of finding out how much time a particular function takes, but we are not going to get into that. It's slightly advanced. Maybe by the end of the course we'll be able to teach you what is called profiling, in the sense that you can find out how much time your individual line of your code is taking. I mean, that is simply put, it's a lot more complicated than that. Let's not get in there. But the point is, you by now know how to find how much time a particular function takes. So far so good. The next thing that I want to tell you, make you recollect, because these things are coming for the next upcoming discussion. Let me clear the screen. Integral part of 10 plus, let's say 10 by 2 is what? Let's say 10 by 3. 10 by 3 is 3.33. So integral part of that is 3. Alright. You know this very well. So there's another way of doing this. If you put 2 slashes, okay, that's an easy way to compute. Instead of simply saying 10 by 3, which gives you 3.33, when you put 2 slashes, it will give you the integral part. Okay, keep this in your mind. I'm going to recollect this as I'm going ahead with my program. Right? Okay, now let's go ahead. You now know what is this operator, and you also know about import time. One thing that I would like to make you realize is the small exercise. Let's say L equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 maybe. Alright, there are 10 elements here. Len of L is 10. Correct. So what will happen if I want to find the middlemost element here? Okay, so let's say first element is 0. The last element is 9. How do you compute the middlemost element? All you need to do is simply do begin plus end divided by 2. Okay, that's how you find the midpoint, and the midpoint is 4. Okay, you might question, why is it 4? You see, there are 1, 2, 3, 4, 5 elements on this side, 1, 2, 3, 4, 5 elements on this side. Okay, it can as well be 4 or 5. Alright, but then when we take begin plus end integral part divided by 2 integral part, it gives you 4. If you add 1 to this, it may give you 5. So ideally, this is the formula to find the midpoint. But what if you had, let's say, odd number of elements? How many elements do you have here? The answer is not 10. Please note 10, 1 to 10 plus another 0, which makes it 11. So length of L is 11. So what if we execute the same code, begin plus end by 2? It will actually give you the center point 5. Okay, let's try doing that. You're getting center point 5. That's because your begin and end continues to be 0 and 9 here. Begin is 0, end is 10. So you see, this has nothing to do with the list. I'm just trying to tell you how to find the center point of any list. Okay, begin is 0, end is 10. So begin plus end by 2 is 5. That's the center point of a list that starts with 0 and ends with 10. Essentially has 11 elements in it. Whenever a list has 11 elements in it, begin is 0, it starts from the 0th element, goes up to the 10th element. There are 11 elements you figure out by adding begin plus end by 2. So what have we inferred? We infer that begin plus end by 2 gives us as the midpoint of the list, which has of the list starting from begin and ending in end. Okay, that's pretty straightforward. You see, you may be wondering, sir, what are you trying to say? I'm a little confused. All I'm trying to say is, what's the midpoint of, let's say, this? How do you find that? The midpoint of simply this will be, then you should choose begin to be 3, correct? End to be how much? What was that? What did I select? 3, 4, 5, 6, 7, 8. Okay. End is 8. Begin is 3. End is 8. 8. The mid should be 5 here. End is 8. So I do this Mid is 5. Right? So whenever you give begin and end, it will give you the midpoint. Why are we even talking this? These things will come in between when we are writing the code for something that I'll tell you right now. I'm just getting you people warmed up. Okay? Getting you people mentally prepared for what is coming next. So let's jump ahead and try to see how we can write a piece of code that does better on searching. What do you mean by better? Let me illustrate that in a minute. Let us recollect this code here, which we wrote for what? The obvious search. Let me clear the screen and then let me, you know how I can run this particular code? There's a way to run this particular code on this shell. What you do is you say import and then the file name. What is the file name? This file name actually was search.py. Okay, you should be in the same directory and then import, you say search. Wow, this is like an inbuilt function, you see. So just how you say import random, right? Import search also works. Why? Because search is the function that you have just now written. I'm sorry, you have just now written, right? So when you say search dot and then tab, it will show you all the existing functions here. This is the file name itself and obvious search. Isn't that awesome? You can actually write your own function, right? And if you put a question mark here, you should get help, right? But it doesn't show anything because it is the function that you have written, right? But if you want some help also displayed here, you can always write a comment here saying this will check if, so this very same thing, let's paste it here. Given element k is, you will understand in a minute what I'm trying to do. Okay, whenever, I'm sorry, it came out. Okay, whenever you write a comment in the first line, that very thing will be displayed here when you put a question mark. Not displaying because I did not import. I imported search once again and then I do this. Maybe I should reset it. Just give me a second. I'll go out and then come back and then again say import search. Clear screen, import search, and then I'll say search, obvious search question mark. It shows me check if a given element k is present in a list L or not. Okay, you can write whatever you want here. Okay, this function was authored by SRS Iyengar. Proudly presents one of the simplest Python code ever, only 4 lines. Okay, so when you say this, it will show, you should again import and then it will show again. I said you should exit, come back. There's also a way in which you can reload it. I don't want to complicate it for you people. So once written, function will always show you whatever comment that you type in the first line. It doesn't show any other comment later on. It only shows the comment in the first line. Okay, so what should I do? I can say search, obvious search from the list 0, 1, 2, 10, 11, the element 2, yeah, it's found. If I want to find the element 20 here, no, not found. You see, this is a very comfortable technique, rather a facility where you can write your own function. The first one, as you see here, the first one will be the file name and the second one will be the function name. You may take some time to get a hang of it, but then the bigger idea is that you can sort of play around like this, write your code here and then simply import the file name and then call that particular function with the right parameters. Isn't this awesome? You all should probably try doing this. Okay, so now what I'll do is I'll go a step ahead and I will try to create a list of range of, let's say, 1000 elements, and then I'll try to search for the element 20 in this list. Let me put L here so that I can, yeah, 20 is obviously present, but you see 2000 is not present. Alright, so far so good. Let me clear the screen. I would now like to say A equals, you got it right, time, and then I will say print obvious, print what? Search dot obvious search the same list L and the element, let's say 99T. Okay, is it there or not? Let's see. B equals time dot time. It just came to the next line, that's all. And then I'll say print B minus A. Okay. There's a small mistake here. Print search dot obvious search, and then I should close the bracket here. Okay, and then rest is fine. Time is not defined. I must import time here, and then I'll redo this. It will show me the time that it took to give me this answer. You know, it just executes in a fraction of a second. You don't even know what just happened. All right, so you record the initial time, you record the end time, in between you execute some function, and finally print B minus A. It will tell you the time that this function has taken. All right, so as and always, let me try increasing the length of the list to 1 million, 10 million, let's say 100 million. Okay, take some time to even create this list. Okay, and then I'll try to find the element 990 here. Boom, that was very fast, as though there is no difference between a bigger list and a smaller list. But look at this. If I were to find not the element 990 but an element close to this length of list, which is 999, let's say, or let's say something that is outside the list. Okay, I'll make it a big number. Right, now look at this. It took more time. It took 2 seconds. Why? That is because, please note, why? Because it went through, let's spend a minute on it. I think let me clear the screen and then redo this so that it's easy on your minds. Okay, I'm waiting for a very big number that is not part of the list. It is not part of the list, it says, right? And then it also says it is not part of the list. It says it also takes close to 2.6 seconds. That's a lot. Why did it take such a long time? Because it went through the entire list. That big list that I created, 100 million list, right? A list of size 100 million. So it went through the entire thing and said, oh no, I didn't find this number. Okay, as opposed to, let's say, how much time did it take? It has taken 2.6 seconds. If you were to find a smaller number, right? Let's say if you were to find not this big number which is not in the list. Assume you only want to find the element 9 here. Okay, 9 is there in the first part of the list, you see. No time it will execute. Why is this? This is because in your very list, the element 9 is 0, 1, 2 up to 9 is here, and your 10 million long list, it doesn't go till here. It returns, you see, it returns 1 the moment it sees it in the first part itself. Okay, but when you include something that is not part, that's not part of this list. Okay, if you include a big number here, or if you even include anything that is in the end of the list, okay, the end of the list, if you include, it ends up taking a long time. Okay, makes sense, doesn't it? Okay, so let's get back. Alright, so what did we learn so far? We wrote a simple code for obvious search. We saw a few things which I said, please my friends wait, these things will appear very soon in the lecture, and we went ahead and then we showed how we could use this time library function. Okay, and this particular obvious search thing is taking a long time for a list as big as, how big was the list? I forgot. The list was how much? 300 million, right? This is 100 million, correct? Am I right? This is 1 million and this is 100 million. Correct. So 100 million long list took a long time. Is there any way we can write a function? Now here's the question. Okay. A question. Can we write a piece of code that searches for a given element in the list L faster than the obvious algorithm given above? Okay, doesn't look like there is an algorithm. Let me take a break now, think if there is one such algorithm, and then get back. By that I mean you meanwhile digest whatever we have covered so far. We'll come back to this very same code in our next video and try to write a very ingenious algorithm which uses the idea of the example I gave you, the Hema Malini actress example, the finding of a word in the dictionary example, the halving of a big number which quickly makes it go close to zero or a single digit number example. I'm going to use that example in writing a very ingenious code that will work in a matter of fraction of seconds. I mean, if it's a fraction of a second, it will work. We cannot compare that with the obvious search. Okay, this is actually a very, very expensive algorithm. It takes a long time. Okay, let's see in our next video.